My name is Adam Bunker, and this is my presentation on the math behind guitars and equal temperament. So why this subject? Well, first off, just because I like to play guitar and it's a hobby that I enjoy and would like to someday, fingers crossed, turn into a career. And I think in order to do so, it's just important to understand the complexities behind guitar and music overall, which means understanding equal temperament and other sorts of things along those lines. And second off, well, because my dad runs a guitar making business, which he inherited from my grandpa. Excuse me. And both of them have used equal temperament and all this math basically for lots of parts of their jobs in making guitars. And my grandpa, who is in this picture to the right, was basically a genius when it came to all this, and not only understood equal temperament, but basically everything to do with music, and was kind of like a genius when it came to all of that. So it's a pretty big inspiration for me. So what is equal temperament? So it's a system of tuning in Western music, and it divides the musical octave into 12 equal semitones. And so basically each semitone goes up by the same frequency ratio, which you can see here. And so basically this allows for instruments such as guitars, pianos, and lots of other things to be played in the same keys more easily, and allows chords to be played across the instrument without having to readjust for different scales. And so basically overall simplifies the process of tuning and playing the instrument overall, making it less complex and more easy to put together different sorts of keys and notes and stuff. So here's the first custom learning aid I had made for you by ChatGPT. And basically with this one, I basically just told it to make me a learning aid explaining equal temperament and the math behind the spacing of guitar frets. And so this is what it gave to me, and I think I just wasn't specific enough with this prompt. And it is good at showing the equations for the string length and distance from nut and all these things. But I think it doesn't exactly show how to apply them. So after making this one, I decided to go to my dad and ask him how he uses equal temperament and these things in it for his work and for actually making guitars. And so that led to this next learning aid, which so he drew me up little, basically this, to show me how it works. And so I took a picture of what he drew up and gave it to ChatGPT and sort of had it translate it into a digital version, and went through that until I had a version I was satisfied with. So I'll explain all of this real quick. So basically you have the 25 inches scale, which is the distance from the bridge right below the big hole on the guitar to the nut right before all the tuners. And then you have the frequency ratio, which is the 12th square root of 2, which is 17.817, which isn't exactly the same as what was shown before, but this is what he uses in his work and for actually making guitars. So I think this one is more accurate. And so basically you start with step 1 by dividing the total scale, which is 25 inches, by the frequency ratio, 17.817. And so that gets you the location of the first fret. And so you divide those and get 1.403, which is the distance from the nut to this first fret here. And so step 2, to find the second fret location, you subtract nut to first fret length. So the 1.403 from 25, and that gives you 23.597. And then you take the 23.597 and you divide it again by the frequency ratio, and that gets you 1.32 as the distance to the second fret from the first fret. Okay, and then so for step 3, so you repeat the same process. And so yeah, you repeat the same process that you did with subtracting 1.403 from 25, but instead with these new lengths. So subtracting 1.32 from 23.597. And on the original picture, it had the math here, but ChatGPT just would not put that in for some reason, so it doesn't show that. But that ends after subtracting those, then dividing them by the frequency ratio, the answer by the frequency ratio, it gets you to 1.25. And then so step 4, basically you repeat that same process with subtracting, with getting the fret length, subtracting it from the new number, so from like the 23.597 in this case. So basically you keep going down and until you get to the and doing the same process just with the new fret locations and scale lengths until you get to the very end of the fretboard down here. And that basically makes it so all the strings are divided into the octaves that they need to for the guitar to have its best sound and for notes to be played all across the board. And also, just one more thing, this is the original example here that I used for reference for this last one, if I can go back to that. Yeah. So here's this one, and here's the original one that my dad drew up for me. And yeah, you can see down here it actually has the math. So yeah, step 3, subtract like 1.32 from that, get that, and then you get 1.25 inches. And then you would take 22.277, subtract 1.25, divided by the frequency ratio. And basically continue that same process until you get the point. And then, yep, that is pretty much it for the presentation. And thank you for watching.